I want you to understand what the meaning of the words description. Okay, so all I've done is I've taken the pseudocode. Okay, this is the pseudocode. So basically this keeps going. Okay, while there's no interrupt, it's going to loop forever because it's a fetch execute cycle, and we're going to copy the value. So the fetch execute cycle works like this. So the fetch part is copy the value in the PC to the MAR. So let me put a comment in there. So fetch part, right? So copy the value in the PC to the MAR, access memory at that address specified, okay, in the MAR, and then copy the value to the MBR. At the same time, increment the PC. So increment means to add 1. And then we copy the value from the MBR into the CIR. Remember, in this fetch execute cycle, nothing comes in or out of the processor except by going through the MBR. It must go through the MBR, in or out. So now we decode the instruction. Now look, I've put 3 different types of dealing with the instruction. So for simplicity's sake, we might want to load a value from memory. Okay, so if we need to load it, we've got to copy that address from the instruction to the PC. So the address will contain the instruction will contain the address to which to copy, from which to copy or load the value. Okay, so we've got to use the MAR so that it can access memory. There's only one way to access memory, and that's by having the address in the MAR, and then whatever's in the memory comes into the MBR. So we access memory at the address in the MAR and copy its contents to the MBR. Okay, then we copy the value from the MBR to the accumulator and we carry out the operation. So it might be, well, in this case, we're just putting it in. Okay, we might be adding, we might be subtracting, okay, but the data's come from memory. If the instruction uses a value, okay, then we don't need to go and fetch anything. Okay, the instruction contains a value, so we just take the value from the instruction and put it into the accumulator, into one of the registers. If we're storing, then we do the opposite. So we've got to take the value from the accumulator, put it in the MBR, because that's what's going into memory. We take the address from the instruction and put it in the MAR, because that tells us where to put it. And then we access memory at that address and copy the contents of the MBR to it. Okay? Remember, we can only get to memory if the address is in the MAR, and if then the data comes into the MAR or goes out, or comes into the MBR or goes out from the MBR. Okay? And then if the status register detects an error, then we set an interrupt and we don't go into loop and we handle the interrupt, but then we carry on. Okay? So all I've done here is to put that into words for these instructions. Okay, so copy ABCD from the PC to the MAR, access memory at ABCD and copy its contents to the MBR, increment the PC, okay, copy the instruction from the MBR to the CIR, and then this one involves loading because the instruction says load. Okay, LDR, so we copy that address, DCAF, from the instruction to the MAR, my fault, okay, to the MAR, and then we access memory at that address and copy its contents to the MBR. So we get hash 45 from the MBR and we put it into the accumulator. Okay, so that's what we do, and then we just do that again but for a different instruction. So we do the fetch bit, okay, and then we decode it. This time it's got a value, hash 15, so we can just copy that into the accumulator, and then the last time we've got an address we're using a store, but we do the same again. We copy the value from the accumulator to the MBR, copy the address from the CIR to the MAR, and then we access memory at that and put the value into it. Okay, so this is what we want you to do. We want you to write this out for the 2 examples that you've got. Okay, you need to be able to do this in an exam.